Hey everyone, I am so excited for the interview today. This is going to be one that we've been working on for a little while to get happening. So, super excited for the particular discussion that we're going to have. I'll introduce Tomek from ExxonMobil. He can actually introduce exactly what he does, and we are going to talk all things sort of oil companies and motorsports. So, very very excited. Tomek.
Great. Thanks for having me on the show. Pleased to be here. So the name is Tomek Young. I look after motorsports technology for ExxonMobil as a global technology manager in that space. And ExxonMobil, so maybe I should speak just briefly about the company. It might be known, depending on where you live, under one of our brands. And the brands include Exxon, Esso, and Mobil. We actually have also, in Asia Pacific, we have the federal brand now in Indonesia, which is
Yeah,
also
right.
ours.
I forgot about that. That was a couple of years ago, wasn't it? So let's just get straight into it. I guess one of the questions that a lot of people might have is what exactly are oil companies doing in motorsports, right? And the reason I ask that is because let's say if I put my advertising hat on or my marketing hat on, if we slap a Mobil sticker on the side of a car, I would argue that most motorsport fans are well aware of who Mobil are, right? So you're sort of preaching to the converted. So what exactly is the relationship that, Mobil has with race teams, and what's the nature of the sponsorship and all that kind of stuff?
Wow, this is quite a question. And definitely there's this element of brand recognition that you try to gain through sponsorships and through partnerships that we develop. But maybe one thing that I should touch on immediately, as a technology guy, we are in it for technical reasons.
Correct.
So the technical arm of ExxonMobil, which is our research and engineering company, is in motorsports, supports motorsports to advance the science technology to develop molecules and compositions that give the user an advantage. And in this particular case, it would be a racing team or a racing enthusiast that's getting this advantage. But this type of work extends to other areas in which we work.
So is it fair to say that it's kind of like, I don't know, it's almost like an excuse to do R&D?
Well, I know what you mean, but not entirely.
Okay.
If you look at lubricants development, these tend to be long-term projects.
Yeah, right.
Even in technology areas which are moving quickly, such as passenger vehicles, where you're dealing with specification changes, we can argue relatively often. Still, development programs take several years. If you look at GF6, GF6 Plus, the recent ones, it took every company and additive suppliers multiple years to develop. In motorsports, the technology is moving at a much faster pace. And that's one of the reasons it's so exciting for us. We can test things, we can iterate quicker. Second aspect that I would immediately touch on is the fact that being in that car, being in that motorcycle is not a given. The fact that you're a sponsor doesn't even automatically make it possible. You need to give the team an advantage. And this is like this ultimate benchmarking opportunity, ultimate prove-out opportunity, where you're going to be placed in that engine, in the differential, in the bearing, in the chassis element, only if your product is better than what was used or what is currently used. So this gives our chemists, our engineers, an opportunity to benchmark ourselves against some of the best. This gives us an opportunity also, once we are in that car in year one, next season, there's an expectation of an improvement. And this improvement needs to be measurable in some dimension. Usually it's power that we talk about. Could be also durability, could be, higher temperature running, etc. We need to improve that product again. So if you think about it, at a minimum, you have an improvement for each product that we have every year. So technology development process is shorter and we iterate faster. We tend to get the results much quicker. And then we try to extend the technology to other areas.
Yeah, that's really interesting. So maybe one question that comes out of that would be, my experience in the industrial world is that often benchmarking is quite difficult to do in some circumstances, right? Because, you go to site and there's just so many variables. We would try to do, engine oil comparisons in power stations or turbine oil, gear oils, whatever. And yeah, trying to control all the variables was quite difficult. So if you're being benchmarked, let's say, for example, in a motorsports team, is it, let's say, mostly on a dyno, I guess, because on-track conditions would be quite variable, right?
Well, yes, often a lot of testing will be done on the dyno. But interestingly, as you develop your engine, it's not necessarily, the final engine that you're working with. That engine, no matter on a series, is worth a lot of money. So often you might use some type of a surrogate early on. So as an oil company, we might find an engine that's more accessible to us at a lower cost, do some testing in it, followed by monocylinder testing, for instance, maybe followed by a fired race engine test for power. And then ultimately you would always have, even, before putting any product in the car, you would have some type of no harm or durability test, which is usually in a different dyno, which can run for a prolonged period of time, where you do a final prove out. And then you have that, exciting moment of placing your prototype in the car at a track. And we might do it, at a race. We might do it with some type of a young driver test. We might do it in qualifying. And that's the ultimate prove out. And, you are definitely watching with excitement and with pride, but always a bit of worry, right? I mean,
Yeah.
before you prove something out in a race, you cannot be 100% certain.
Yep.
And so the mixture of emotions is quite interesting for people who participate. But usually things go as planned. All of the earlier testing in dynos usually is of value. And, if we like it, if it performs as planned, it then is used for some period of time before you develop something new.
Yeah, cool. That's really
Make no
interesting.
mistake.
Yeah, that really.
I was just going.
Sorry, you get.
I was just going to say, and make no mistake, as soon as you're in that car, motorcycle, the team is, and your own team is going to already be looking at the solution that's next. You're probably already advancing some of the development of the next generation as you're putting your newest and greatest in the car.
Yeah, that's really interesting. I mean, I'd heard it sort of described, most of these oil programs, kind of motorsport described as like the space program for lubricant companies, in the sense that, it's the most extreme environment and sort of pushing the envelope, and there's a lot of R&D that's involved. So it's really interesting to sort of hear how some of that development happens, and I'm sure we'll get into it a bit more. But maybe
if I may, because that's something that I also have thought about. If you look about a car, definition of a car for us might be something that gets you from point A to point B. Often people who are not gearheads would say, my car needs to get me from point A to point B. And, you might also have other definitions of a car. But if you take this one, would a race car do it? And, one can argue, maybe not, right? You need the crew of people to even start it. You need people with computers and fluid conditioning systems running around. You might have not enough clearance. The car probably cannot go slow because there will be inadequate cooling. So these race cars are often really closer, maybe to, some type of a space shuttle, spaceship technology. Certainly you don't hold back technology-wise in any of the spaces. So lubricants, composite, bearings, engines, you use the newest, the greatest alloys, materials, lubricants that you can find. So one could argue that, yes, this might be closer to some other areas such as, space program.
Yeah.
Than really just getting in your car in the morning and going to work.
Yeah. Yeah, that's so interesting. They are definitely, I mean, you look at like an F1 or an Indy car, and that certainly doesn't look anything like a car that you'd use to get to work, right? One question I think that people always have is, I think it's often sold to the consumer as let's say, sort of like a technology partnership. And especially in something like, Formula One or IndyCar and NASCAR, the OEMs talk about the way that technical developments that they make on the cars eventually make their way into vehicles that we drive on the road, whether it's, hybrid systems or new suspension technologies and all that kind of stuff. So to what extent does that happen in engine oils? You're iterating, and you're doing so on a quite a rapid basis. So, how long, well, firstly, do some of those components ever make their way into consumer grades? And secondly, how long would that typically take? Like, are we talking like a decade or something like that?
They do. But again, this is an area that's like rich in detail.
Mm.
So the motorsports technology that we develop at the track extends into the consumer products. And it extends into this consumer space in many different areas. So if we just, start taking it apart, for one, we actually do market to you and other consumers a racing line of products.
Yeah.
And many teams, including some of the top teams, winning teams, use these products sort of off the shelf. They might not have a partnership with us. We might not be a sponsor and a technical partner, but they can buy our technology. They can buy the technology that's similar and very advanced and readily gives them an advantage off the shelf. That's one. Second, if you just sort of go one layer deeper, we have products which are track to street. With some of the leading manufacturers and our OEM partners, we have developed specifications and products which you can race with on a weekend, and then you can commute to work the rest of the week. We do recommend changing an oil after an event, but you can definitely use the same product for your commuting and for your regular use. So if you're a Porsche owner, as an example, we have such product for you. And it's marketed by both the OEM and us as track to street. Very often our relationship with the OEM is actually rooted in a motorsports type of partnership. That's where we look together for new molecules, new compositions, new specifications. And then you look about, extending the technology to the rest of our Mobile 1, Mobile SHC line. And components are definitely something that we look at. And I know you already mentioned it about a couple of times that we develop components in motorsports. And indeed, we formulate our products in-house from components. So we choose base oils and additives appropriately to give a team an advantage. That's how you really do it. It's not sort of selecting Mobile 1 grade A versus grade B and seeing which one is better. It's this development of a custom solution for a team and for a specific car.
Yeah.
And let's say we find, a new polymer or a new base stock that works well. Usually, actually, people who are involved in motorsports are also involved in other programs. So there's this natural dissemination of information. But we also do targeted session. We try to see how we can place the new technology, new intellectual property within the high volume product line. And there are many examples of this being, a successful endeavor for us historically.
Okay. So one thing that you just touched on then was sort of the maybe the development with the OEMs and things like that. One, let's say, challenge I feel like we have in the industrial world, and a few of the interview guests have spoken to this challenge, is the idea that we are, let's say, the recipients of new technologies. So the OEMs will go and develop a next generation gas turbine or gas engine or whatever. And it feels like there isn't a whole lot of thought that goes into the lubricant strategy around that technology. So in the lubricants industry, it always feels like we're playing catch up, if that makes sense. My sense of motorsport is that it might be a little bit different, and that, you guys have an opportunity to be embedded with some of the engine manufacturers at an earlier stage and all that kind of stuff. So how does that sort of shape the way that the engine oil formulations evolve?
And the earlier we get together with the partner in the development process of an engine, the better. So some of the early tasks for an engine designer might be defining displacement, stroke, bore, might also be defining the size of bearings. And, I actually started in industrial as well. So the industrial area is very close to my heart. And by the way, we have many products which are of industrial nature in some of the series. But for engines, specifically for engine oil, if we can be present at that stage where an OEM, or it doesn't have to be an OEM, maybe some, racing outfit that develops the engine, when they're deciding, how to make the bearing, what treatments to use, what type of metals and non-metals to use in that engine, the better for us. We might tell them, we have experience with hydrodynamic lubrication in that type of bearing. And you can maybe make it a bit smaller, a bit bigger because of the oil technology that we can explore together, because of the space that we can explore together. So at that point in a partnership, we actually keep our options really open. So we don't have a product in mind yet. Viscosity grade is not defined. Friction modifiers and other additives are not defined. We are looking at it very broadly. And that's really an optimal situation for us.
Yeah.
We're lucky that often this is the case. Because of the duration of our partnerships, we often get to work on a new generation of a power unit. However, at times, of course, you enter a sponsorship or a technical relationship at a point where the engine is done. But these tend to also be satisfying. Because, we are in it for a challenge, and we are often told now, the products are optimized. There's not much you can do. ExxonMobil, in that space, we love working with you. We want to see what you can do, but we are convinced what we have is optimized. So, this gets our creative juices going, and eventually a solution emerges. Make no mistake, that's true about technology in any industry. Eventually, a new solution emerges, which is better. That's just so exciting because it can be very different. Often it is very different than what you have used. And then again, you have this opportunity to maybe in 2 to 5 years use it in your commercial product as well.
Yeah. So I guess the engine development in race cars tends to happen sort of on two streams, right? So the first is just evolution in time. We're trying to optimize performance. And then the second lot of changes is usually brought about by rule changes, right? Whether it's a standardization of an engine or, homologation, there's infinite combinations of rules across the different motorsports, right? So how do some of the rule changes shape engine oil strategy? The one that sort of most comes to my mind, just because I'm sort of an F1 fan, would be the way that in F1, the teams are now allowed to use far fewer engines per season than they would have in the past, right?
Mm-hmm.
I think back when I was watching in mid 2000s, it was like an engine for every 2 races. And now it's 4 engine blocks for the entire season or something like that. So how does that kind of, let's say, trying to optimize between performance and reliability, how do you guys approach, I guess, threading the needle between those two requirements?
And right, this is a great question because it's an interesting area of motorsports, and not just for Formula One, but for NASCAR as well. But since you touched on Formula One, you have this yearly allowance of 3 engines, and really it's 3 power units. There's some more intricate detail to it. There are many parts of the power unit, and the number that you can use is on average 3. And what happens is all of a sudden, in both NASCAR, Formula One, but also in any other series due to cost, you're dealing with a situation where durability matters a lot. Your competitiveness during the season, your success in a season depends on how well you maintain these engines. And we know, of course, that these engines tend to degrade sort of over time. So depending on the manufacturer, maybe your power goes down, or maybe you can deal with an increased chance of a catastrophic failure event. And certainly I was excited about the question because it is an area that it's very close to our heart. Durability, use of components and use of base stock approaches which give you durability is something that we have worked on in the commercials or the passenger vehicle, commercial vehicle space. So now we can almost extend our knowledge from our mainstream lubricants and bring them into the racing space.
Yeah.
If we can give the team peace of mind, it really is priceless.
Yeah. Hi, it's Rafe here. Hope you're enjoying the interview. Now, just to quickly butt in, if you find the training content on this channel particularly valuable, consider going over to the website Lubrication.expert. I've been uploading short lubrication courses there, and you can access it for just 10 Aussie dollars a month. That's about $7 US if you want to talk in real money. So as you know, my conviction is that lubricants are an undervalued asset, and providing a low-cost training solution is just one of the ways I'm trying to fix it. So again, www.lubrication.expert. Thanks. And now I'll let you continue with the interview. I never really thought about that. So there is an opportunity for the development to go in reverse. So rather than from, motorsport down, it's actually coming from the sort of the passenger vehicles up.
Absolutely, because durability is so close. When you buy that car, all you think about is durability, no deposits and durability. And with our synthetic formulations of Mobile One, Mobile SHC, we really, Mobile Delvac, we cater to that need that every one of us has. And so absolutely, you can use the same knowledge. And I'm also thinking, right away about used oil analysis, which you have touched on in your show. I watched a few episodes, quite enjoyed it. We have some laboratories for these different racing series. And actually, believe it or not, some of them are mobile. So we take analytical equipment around the globe and, across the continent to be able to provide input into the team as the weekend progresses. Different engines might be used, for qualifying, for practice, for racing. And we can take a sample of the oil from this hot car as soon as it arrives in the garage, test it, put it in our database. There's always somewhere. So you need a lot of experience. You need to be able to sort of know from this complex data set, how you're doing. And we collaborate with the team, with engine supplier, and to, crack this data and decide, can the engine be still used? How much power? Are we going to have this predictive ability, which lubrication scientists and engineers love so much, and used oil analysis can give it to you.
Yeah, right. I hadn't really thought about that, because you're right. Like on passenger vehicles, we don't tend to do used oil analysis all that much, right? I mean, you often see used oil analysis results come up on, like the Bobby's the Oil Guy forum or something like that, but it's not probably a standard part of the maintenance suite. So we're certainly not doing anything, predictive in the way that we would in the industrial space. So it's interesting to see a lot of those themes sort of carried over, I guess, to motorsport. And it probably has to be more instantaneous, right? Like with industrial, you send off your sample and it comes back a few days later, but by that time the race is over. So, I mean, your mobile labs are probably having to do it on the spot, I guess.
Yeah, that's exactly right. In real time. So we not only take samples, but we actually have, these sort of high-grade analyzers that you would see in a lab, not in an industrial setting. So often these are not portable pieces. We make them portable, but they come straight from a chemistry lab. But we can still offer these results, to ourselves, to the partner, to the team within minutes or tens of minutes.
Maybe more of not necessarily business question, but a question about some of the different categories that you'd support. Mobile may either supply or have a technical partnership with multiple teams on the grid.
Yes.
So how do you guys manage that relationship? I mean, I'm assuming that you're covered by all the standard NDAs and things like that, non-disclosure agreements, so that you're not sharing information between the teams and all that kind of thing. But I guess what I more wanted to ask is about, how different are their philosophies to, let's say, engine oil development? Like, do you see a wide disparity? You might be supplying two teams on the grid and they want completely different things out of their oils, or do people tend to request sort of the same performance metrics?
You need to look at a race car holistically. And we have used we spoke about the engine, but really, you need to look at the race car and the race series that it is in, even the racetrack, to be able to decide, to be able to really guide your development towards an optimized product. And because of that, the team strategy, surface treatments, designs, aerodynamics, cooling, oil supply, oil extraction, all of these elements are going to define the environment that the oil is in. Even the way the team drives, some of the shortcomings they might have, maybe in some type of downforce in the curve, they overcome, but by straight line speed, and a different team might rather go after agility in turns. And this changes the appetite of this whole package when it comes to lubricants, and it really does.
Yeah.
So lubricants, even in the same series, and by the way, we often separate these different areas, have different people working with a given team. But what you see is, shockingly, the oils might be completely different. And we often think about, how are they different? We might think about viscosity and elemental composition. Completely different, right? Not just adjacent viscosity grades, but maybe viscosity grades that are on opposite side of the spectrum. And maybe one team, having separate products for certain type of races versus another team preferring just having one product. And honestly, I could go on, but it is amazing.
Yeah.
The product that you end up with after, especially, a few years of a collaboration, it truly is specific to that team. I don't know if we have a situation where we have a different product per driver, but I bet you if you spend enough time, enough resources, you probably could do it.
Okay, so that makes me think of a whole bunch of questions. Namely, so the reason I want to ask this is because I'm getting to what I want to ask is about formulation philosophy in the industrial world and how tailored could we get, right? So the first question I need to ask you is, when you were coming up with these new formulations, how much can it be, let's say, a computer-driven exercise? So with all these iterations that you're going through, I know that formulators use a little bit of software, right, to try and, so that you're not having to create a physical product each time. How accurate is that kind of like modeling software? Do you find that you can sort of reasonably accurately predict performance out of a computer, or are you having to make physical samples each time you iterate?
You tend to do both. And I think, these are some secrets that are really close to the heart of participants in this industry, but clearly computer modeling of physical properties and chemical properties and then performance in finished mechanical system is something that if you can crack the code, make it happen, it gives you a huge advantage because all of a sudden, instead of making multiple blends and running tests, you can predict properties.
Yeah.
Do we do it in mobile, in the area of motorsports? Definitely. Prediction of physical properties, of chemical properties, is often an area that's a little more advanced. When you look at the science, the physics, the chemistry of a fired engine, it is so complex that there's a lot of good attempts, and you can look at specific elements of that engine, but having a really comprehensive model, I think, is still not easily achievable. So investing in a one generation of engine for racing might be hard.
Yeah. The reason why I was asking is because, obviously with your background in industrial as well, I was wondering, how far away are we in the industrial world from having tailored formulations to, to people's applications? Because that's one thing that we do find in the industrial world is that, and this is true of all the oil companies, right? You get, let's say, for example, for gear oils, you get a choice of, let's say, 4 different series, and there are, the ISO viscosity grades, and have at it. But, going back to how we were discussing all the different variables that go into performance, one company may run their gas turbines completely differently from another company. And so they see different performances out of the oil package. So it would be, it'd be an interesting exercise to, iterate as fast as you do with a race engine but apply that to the industrial world.
Definitely. Almost, extending this motorsports philosophy and pace into the industrial world. That's something that, perhaps with advancement in manufacturing, and if we change that approach, that maybe would be achievable. We are a company of huge scale. We have a very large portfolio of hundreds and hundreds and hundreds of products for various applications. They do work well. We select many of them actually as sort of first iterations for some places in the car, looking maybe at hydraulic fluid demand or greases. You would first look at a product that we have and then tweak it and modify it. Eventually it's going to be different, and eventually maybe full circle, the commercial product becomes different. Is this an opportunity? Being a formulator in my past, I think that's something to look at. And, could one create a new manufacturing paradigm where this is achievable?
Yeah.
Perhaps.
Yeah. Fun to think about. So again, speaking to the future, a lot of the different race series have big rule changes coming up. right? So, F1 has obviously pushed, well, most of the race series have pushed a lot of the rule changes as a result of COVID. They've sort of extended the current rule paradigm for an extra year. There's obviously a lot of talk in F1 about, the big rule changes coming up in 2026, but also the new cars in 2022. NASCAR, similar thing, right? We're going to, generation 7, I think, of the NASCAR technology.
Yes.
How much can you talk to how that changes, let's say the oil strategy? Like, are the changes in the engine and the car overall so big that you're basically wiping the slates clean and starting again? Or is it an exercise in adaptation?
The cars are changing dramatically. So use the example of F1 and NASCAR. In NASCAR, we are going to, it's still a tubular chassis, but that's probably about it when it comes to similarities. The body is manufactured completely differently, and it's a one piece. And, it looks more like a road-going car. I think it will get a lot of us excited because the product, the 2022 NASCAR, is very relatable. You probably would want it in your garage all of a sudden. But you look under the chassis, the engine remains. The engine is similar, the same. There's some power adjustments potentially that are still being discussed. There's cooling adjustments. So the engine manufacturers, the engine suppliers will have to respond to those. But the spec, let's call it, didn't change dramatically. It's not like going from a V8 going to 2014 in F1 to a V6. That was a dramatic shift. However, then you look at it, the gearbox that was used, the 4-speed gearbox for NASCAR is changing to a sequential 5-speed transmission.
Yeah.
A bit similar to a motorcycle gearbox.
Yeah, right.
Which is a big departure for the driver, but also a completely different lubrication problem. And all of a sudden you have this center shaft, high-speed center shaft extending from the engine to the transaxle in the back now, which has the transmission in it, the differential, and you have half shafts going into the wheels in the back. So, even if you for a second separate yourself from the engine oil that's in the engine in the front, and maybe even from the gearbox oil in the back, all of a sudden you have, high-speed shaft and bearings and CV joints in between. And of course, this creates interesting opportunities for us as lubrication scientists and the teams, NASCAR have experienced some, there were opportunities created for us to which we responded with products from our repertoire and with some, customizations that we can make. For the engine, there's a definite desire by the series to lower the barrier of entry. So both NASCAR, probably F1, they want to see additional manufacturers come in. And lowering the complexity just a bit allows for people to maybe all of a sudden be in favor of entering. So keeping the engine, more similar, I think it's one of these areas where the barrier of entry is lowered. So both for F1 and for NASCAR, the engine remains, I wouldn't say unchanged, but at least the spec is similar. However, of course, we are working on new generations of oils for both NASCAR and F1 for 2022. And because, the relationships that we have are multi-year, I think the process is on the maybe iterative side, but there are some changes which we'll talk about when we introduce the cars next year.
Yeah, that's pretty exciting. It's interesting to see the evolution, and NASCAR is obviously pretty exciting because, like you said, the cars are going to look dramatically different, right? Well, that's actually true of NASCAR and Formula One, right? The new Formula One car looks
quite different.
The aerodynamic package is very different, and the NASCARs are looking, well, the body at least looks a lot more like the commercially available cars on the road. So I think there'll be some really interesting changes. Then obviously F1 into the future, there's talk about removing the MGUK and the MGUH, to try and, like you said, lower the barriers to entry. But we'll see how that all shakes out. One thing I was going to ask you about, actually, I don't know if you can actually, I don't know if you can speak to it, to be honest. There was a bit of press earlier in the year about Mobil's involvement with the Red Bull team and some performance advantages that had been gained as a result of some formulation changes to the oil. the talk in the press, at least, was that you had pulled some additive components from, let's say, outside of the typical industry, and the talk was that it was pulled across from the cosmetics industry. Are you able to talk about that at all, or are you kind of, is it cone of silence and you're covered by non-disclosure agreements?
This was one of these moments where you watch the car with this added pride. We did introduce an upgrade earlier this year to the oil, and indeed, one of the molecules that is used in that formulation was borrowed from cosmetics industry, so was not traditionally used, at least by us ever, in the space of lubrication. And when we look for opportunities with these products that we develop look for opportunities to improve performance, ultimately the molecular composition is one of the areas where we can deliver differentiation. And what we discovered as a company, and I think this is really historically true in many areas, finding new molecules can change the game. And I think this is probably true for mobile, going really far back. I know the origins of a lot of our products were sort of in like Arctic environments, and we discovered the synthetic molecules, so the ones that previously didn't even exist. They were created in a plant, give you an advantage in these environments. Then we extended these advantages to energy efficiency and fuel economy, gave our customers, measurable savings, gave drivers measurable savings in fuel economy. But we continue searching. So the motorsports team is looking at a lot of different molecules, and we find some patterns. We develop these so-called structure relationship molecule properties. So we look at, changing structure of a molecule in some measurements, then try to normalize for the various shapes and sizes of the molecule, and try to develop some understanding of how the molecular structure, the interconnectivity of these atoms contributes to performance. And when we find a pattern, then we look for the extreme molecule. And often this molecule is not something that we have used in the past. And we go get it and find a company that manufactures it, maybe ask our colleagues within the chemical company to make it for us and start testing it. And in particular, earlier this year, we found an oil which worked very well in the changed Honda engine. So the engine design of our B16B car was refined for 2021. And the engine was actually was changed quite a bit by Honda. Honda spoke about it. You can find it in the press. But the smaller package that they developed changed the aerodynamics of the car.
Yeah.
And we tailored the oil to allow for that smaller package to still perform reliably. And the whole combo worked, and there was a ton of testing, let me tell you. Dozens of candidates, a ton of testing, and still a little bit of emotions when the oil was going into the car. But we very quickly decided that this was it, and the partner we were racing with that oil.
Yeah, that's really interesting. It's interesting to hear about those changes because, despite, let's say, some of the rule, not freezes, but there's not that much engine development this year because it's mostly a holdover from the pre-COVID rules, and yet like the Red Bull car of this year looks dramatically different from last year, right? For those who follow the sport, the back end of the car looks almost entirely different from last year. So it's interesting to see, how the OEMs have really responded to pushing the envelope as much as possible within the bounds of the rules that have been set. So
yes, the engine and the package were definitely changed.
Yeah. It's very, very interesting. Maybe that comes to one of the last questions I might want to ask you, which would be the way that you talked just then was, it almost sounded like the way a pharmaceutical company goes about discovering new drugs, right? In the sense that, I've got friends who work in the pharmacy industry. The way that they talk about it is it's just, you are swimming in, an infinite number of combinations when it comes to organic molecules, and you just try to hit on one that works. There is a bit of, predictive capability, but that predictive capability is not perfect. And so you still have to go out and discover new molecules and test them and all that kind of stuff. Now, with what I understand with the oil developments from earlier this year, you said you pulled over a molecule that had never been used before, and the talk was from, let's say, the cosmetics industry. Are there other industries that you're actively looking to, let's say, cross-pollinate with to, to what extent has, the knowledge within the chemicals industry is kind of known by everyone, and now you have to sort of branch further afield for, performance improvements?
The one partner with whom we work on new molecules quite a bit is our chemical company within ExxonMobil. So we're fortunate to have a chemical company that produces, but also researches molecules, including polymers, base stocks, synthetic base stocks. And there was a bit of news recently on new types of molecules from them, and we actually do use them, find them to be beneficial in motorsports, and they hopefully are very beneficial in other areas as well. And we're constantly exploring. There's always development. I have to tell you, with this oil that we released, the engine oil for Red Bull, if you look at the very beginning of that program, of the technical program, we're not exaggerating when we say it's a decade. It's not because we're slow, or maybe, but it rather takes time to pinpoint an approach that works holistically, that gives you that combination of durability, power, cleanliness that you're seeking. And I remember distinctly when we started that program. So we had a discussion with the team, we were trying to pinpoint the time when we started looking at the family of molecules that ultimately we landed on. So we're already working on new ones and always searching. And that's, I think, one area where you often succeed and do deliver differentiation. So your efforts tend to pay off.
Yeah. Wow. Well, and that feels like a sort of a natural place to end it. Tomek, thanks so much. I feel like I learned a lot, about the company's, place in motorsport, and how, lubricant companies in general. I didn't realize that maybe the degree to which you guys are embedded with, the OEMs and the race teams, and exactly how tailored some of those formulations can get. It's very, very impressive. So yeah, really appreciate your time. Thank you so much. And hopefully I'll get you back for round 2.
Great. Thanks so much for the time. I really appreciate it. I enjoyed the conversation.